Okay, so now we're back, right? And we're still doing something similar, but you're going to notice a plot twist here, okay? Same scenario that we've been working with. Suppose a normal model describes the fuel efficiency of cars that are registered in your state. The mean is 24 miles per gallon with a standard deviation of 6. Describe the fuel efficiency of the worst 20% of all cars. Now, without even reading step 1, let's just try to think from our head. What have we been doing? We draw the curve. Okay, we put our mu. We put our sigma, standard deviation. Okay, now here's the catch. We don't have an observation. We want to know an observation, and that's a spelling error, I'm sorry, okay? We want to know an observation. We want to know what car has a fuel efficiency of the worst 20% of all cars. Well, this whole thing has an area under the curve of 1 or 100%. This top half is the top 50%. This bottom half is the lower 50%, okay? So the worst 20% would be somewhere over in this area, okay? Upper 50%, okay? So that means we're dealing with like 60, here's the 50% mark. 50% have a fuel efficiency less than 24. That's the mean. That's 50% always when you have a normal distribution. So this might be 60%, 70%, 80%, 90, all the way to 100%. Right here, we're going to just mark an arbitrary point. We're going to say, we don't know what observation this is. We need to figure it out. But what we do know is it describes the worst 20% of all cars. So what you notice is I changed that to a decimal. You always want to do that in these problems. I actually prefer decimals to percentages, okay? So we're describing the worst 20% of all cars. We need to know what observation will give us 0.20. So what we're doing is we're doing Z in reverse. So step 1, we draw the curve. We did that. We marked the mean, the standard deviation, and then we shaded the percentile approximately where we think it should go. Just make sure it's on the right side of the mean, okay? So again, write down if you need to. This side of the mean will be anywhere from 50 to 100. This side will be anywhere from 50 to 0, okay? All right, percentile always means less than. Okay, next what we need to do for step 2, okay, instead of going outside in, we need to go inside out to find what z-score will give us a percentile of 0.20. So let's do that now. Now, some people say, oh gosh, do I want to deal with negatives or do I want to deal with positives? Well, you should notice we are below the mean right now, which means we will have a negative z-score because a z-score measures the exact standard deviations above or below the mean. So if it's a negative z-score, we're below the mean. So we want to be on our table A, we want to be on the negative sides. Now inside all of here are all of our p-values, our percentiles, our proportions. We want to find the closest one to 0.20. So you can see here's like 0.14, here's 0.22, here's 0.2033, here's 0.2005, here's 0.1977. Which one is closer to 0.20? And this one is right here, okay? So now what I'm doing is I'm going inside out instead of outside in. I'm now going to arrow over to the right to see I have a z-score of negative 0.8. Those are the first 2 digits. 4, okay? A z-score of negative 0.84 gives us a percentile of approximately 0.20. We get 0.2005. Okay, so let's write that down, negative 0.84. Okay, so that was step 2. Step 3, plug in what you know into the z-score formula and solve for x. Okay, so we know we have our z-score, right? Here's our formula here. So we're going to plug in what we know. We have our z-score, negative 0.84 equals our observation. We don't know that. That's x minus our mean, 24, divided by our standard deviation. Okay, and now we need to solve for x. And I should note, as you guys are doing this, you do need to be showing your work. I know some of you are going to say, oh, I can do that in my head, but you have to show your work for z-score and going backwards, so on and so forth. You don't have to show your work how you get for x here, but you have to show that you plug this stuff in, okay? So if you've forgotten algebra a little bit because it's been so long, first what I need to do to get x by itself, I'm going to multiply 6 by both sides. So I'm going to take negative 0.84, okay, times 6. And that gives me negative 0.504 equals x minus 24. And now I need to add 24 to both sides. So that gives me 18.96. Okay, so describe the fuel efficiency that of the worst 20% of all cars. That fuel efficiency is 18.96 miles per gallon. Perfect, guys. You're doing great. Keep it up. Let's go to the next problem. Okay, what gas mileage represents the third quartile? I put this in here. I'm not going to actually do it with you because it's the same thing that we just did, and I want to save you time. But the third quartile is the 75th percentile. Okay, so you would try to do the same thing. Now, what I want to encourage you, if you want practice, to pause this one and try this one on your own. And then you can come to me in office hours or come early back to class and check, did you do it right? Okay, same steps. I want to actually move on to the next one. Describe the gas mileage of the most efficient 5% of all cars. Okay, same type of problem, a little bit different. I want to go ahead and see if you can do step 1 on your own. So pause it right now. I'll do the same and we'll come back and we'll match it up to see if you have the same. If you didn't get this, don't worry. Let me talk you through it. You should have a mu of 24, a standard deviation of 6. Now, how did I know to go over here? The most efficient miles per gallon, okay? You want high miles per gallon, okay? Right? That's an efficient car. If you didn't know that, now you know, okay? I have a Ford Explorer. It doesn't get great mileage. It means I'm filling up my tank more, so on and so forth. I'm over on this side. But if you drive a hybrid car, you're getting a lot of miles per gallon. You're over on this side. Most efficient, okay? 5% of all cars. That means the top 5%. Okay, so this one right now is a Z in reverse, but the difference is it is a greater than problem for Z in reverse. You can imagine if you're in the top 5% of the class, that means you're in that 5%, 95% of people are doing worse than you, okay? You're in that top part. Most efficient means top. Okay, with that being said now, we need to go to the table and we need to go inside out again. But I have this little note here. We need to analyze if it's a less than or greater than, and this is a greater than. Now remember, the table only works for the less than. So in order to find a z-score that gives us the top 5%, the most efficient 5%, we actually have to find the z-score that is equivalent, as in less than, which would mean the 95th percent, the rest of this, okay? Those z-scores will it'll be the same thing. If you are scoring better than 95% of people, that means you're in the top 5%, okay? You're in the 5th percentile of your class. So hopefully that made sense. If it didn't, mark it as a note and we can talk about it more. I'm gonna go and find the z-score that is associated with the 95th percentile, which means I will be in the top 5%. Okay, let's do that now. I'm on the right-hand side. I'm above the mean. I'm going to have a positive z-score. Okay, I'm going inside out. I want to find the percentile that's closest to 0.95. So I see right here 94.95 and 95.05. They're both equidistant from 0.95. So what we're actually going to do is we're going to cut it in half or split the difference. Okay, we know that the z-score associated with it, the first two digits are going to be 1.6. Then what we do here is the middle of 0.04 and 0.5 is 0.045. Okay, so this z-score is actually going to have 3 decimal places. Okay, 3 decimal places. The first, right, is going to be 1.6. The last part, now remember, before we never took the 0 here. This is just describing what the 100th place should be for all z-scores, okay? This is talking about the 10th place. Okay, so our 100th place is 4. And then we need one more here, 5. So the z-score associated with the 95th percentile, which means we're in the top 5%, is 1.645. Okay, now what I want you to do is I want you to try step 3 on your own and see if it matches up with mine. Okay, so I plugged in what I knew, ZOMS. My z-score is equal to 1.645. For observation, I don't know that that's x minus the mean divided by the standard deviation. I multiplied both sides by 6 and I added then 24. Now, all I expect for work is this right here and this when I talk about showing your algebraic work, okay? All right, let's move on. An ecology group is lobbying for a national goal, calling for no more than 10% of all cars to be less than 20 miles per gallon. If the standard deviation does not change, what average fuel efficiency must be obtained? Okay, always, whenever you see the normal model, just get in the habit of drawing the curve because sometimes it'll be a little bit more difficult, like this problem. But when you draw the curve, you can kind of see it and it will come to you. Okay, because you're like, oh yeah, what do I know? I know ZOMS. What can I do from here? Blah, blah, blah. And you can figure it out. Okay, so what do I know? Let's do it that way. Let's approach it that way. I know I have the normal model. I know I have a mean of 24. I know I have a standard deviation of 6. Now, do I have an observation? I actually do. It talks about being less than 20 miles per gallon. And this ecology group wants no more than 10% of all cars to be less than that. So that 10% has to be the max. So again, I'm going to change that to a decimal right away. If you're like, how do I go from a percent to a decimal? Not a problem. Divide by 100 or move the decimal 2 to the left. Okay. Oh, here's the catch. Here's the catch. I marked the 6 because that's what I read. But what is the question asking? The question is asking if the standard deviation does not change, so that stays the same, what average fuel efficiency must be obtained? Okay, so now I need to change this, right? So that's why I like to mark the curve, reread the question, adjust as we need to, because this one is more challenging, and say, now I actually don't know what the mean is. Okay, well, I know ZOMS, right? That's the next, I'm trying to kind of coach you through the problem solving. I set up everything I knew, I reread the question, and I made an adjustment. The standard deviation doesn't change, but we don't know the mu. Well, how are we going to find the mu? Well, I do know the percentile here, okay? I know this proportion. So I could now go to the table, inside out, and find what z-score is associated with this 0.10. So let's do that now. Because it's a less than, we don't need to worry about doing a subtraction like we did in this first one, or the second one, excuse me. where we said 0.05. Well, 1, this whole thing has to add up to 1. 1 minus 0.05 is 0.95, okay? It's just 0.10. So let's go to the table now. 0.10, we're below the mean, so we're in the negative z-scores. 0.10, I see a 0.1093. I see a 0.1020. I see a 0.1003. That's pretty dang close. So I'm going to go over, and I see a negative 1.28 is the z-score associated with that 10th percentile. Oops. And now what I'm going to do, guys, is I'm going to plug in everything I know. Negative 1.28 is equal to my observation, which I know, minus my mean, I don't know, divided by my standard deviation. So now I need to solve for mu, okay? So I want you to do that now, and I'll talk you through it if you need to. I'm going to take negative 1.28. I'm going to multiply that by 6, okay? Then what I need to do to get mu by itself, I need to subtract this 20. Okay, so now I'm at negative 27.68. Negative 27.68 is equal to negative mu. And I divide both sides by negative, which means mu now is equal to 27.68 miles per gallon. Okay, guys, I'm just about done. I have one more problem up here that's very similar to this. Because of time right now, I want you to try this on your own and come back to me if you have any questions or if you want to know if you did it right, okay? So pause it right here and try it. Otherwise, I think I've done enough where you should be able to understand that. Please come back if you have any questions. Have a wonderful day.